This walkthrough is going to show you how to create a retro-inspired clock that syncs its time with the internet. You can customize the fonts to look however you'd like, and the timekeeping is all synced with the internet so it's always accurate. The major components of this build rely on 5 OLED displays, one for each segment, an I2C multiplexer, an ESP8266 microcontroller which will handle the internet communications, and a 5-volt power supply. In addition to the electronic components, you'll also need to purchase whatever wood, cloth, or stain you'd like to build this with. I used 5 OLED displays to run the clock because LCDs have backlights and the light would bleed through the cloth, leading to an undesirable aesthetic effect. Step 1 is to cut up the wood into whatever size and length you want. For this project I chose pine just because it's cheap and easy to work with. Step 2, and probably the most arduous step, is to hollow out the blocks so you can fit the displays and electronics inside the clock. The method is up to you. Personally, I used a drill and a hacksaw so that there were no gaps in the wood, but a bandsaw could work just as well. Step 3, stain the top and bottom pieces whatever color you like. Step 4 is to wire up the OLED displays to the multiplexer. The multiplexer is important because these displays communicate via I2C. Now the manufacturers get a little lazy at this point and they program the same address for each display. What this means is if you just connect them up and then write an output to a display, every display is going to have the same address, so they're all going to display the same thing. To get around this, we use an I2C multiplexer, which is going to reroute our data to each display individually. Use hot glue to install the displays into the shell, making sure that the front of the displays is flush with the exterior. Carefully wrap and glue the fabric around the shell, making sure that the corners lie as flat as possible, otherwise there will be a gap between the fabric wrapped portion and the stained portion. Glue the entire assembly together, connect your Node MCU ESP8266 module, and see if the whole thing runs. I've included the code for the ESP8266 module in the attached files. You'll need to fill in your Wi-Fi network information so that the device can connect, but aside from that, it should run out of the box. The code connects to the internet every minute to update the time, and if there is a more than 60-minute gap between updates, it determines that something's wrong with the wireless connection of the device, and it reboots the microcontroller. The digits that are output to the displays are actually monochromatic images, as you can see in this picture. Each image is stored in the programming as a large byte array, like this. If you'd like to customize your fonts, I would suggest using a tool like Photoshop and creating black and white GIFs of each digit. You can upload these to an online tool that will convert this image to a byte array. There are several online tools that can do this for you. The resulting byte array can just be copy and pasted into the code. Just make sure that the X and Y pixel counts are the same as what you have programmed in the code.